Earlier in the course, I talked about abstraction as one of the core principles of object-oriented programming. So abstraction means hiding the details and complexity and showing only the essential parts. Remember the DVD player? That's abstraction. Now, to implement abstraction, we use private properties and methods. So we hide certain members of an object so they won't be accessible from the outside. So here we have this circle class. We set the radius property in the constructor. And as you know, this radius property is public by default, which means if I create a circle object, pass 1 as the radius, then I can access this radius property here. Now in this case, we want the radius to be public because that's an essential attribute about a circle. But in this lecture, let's imagine we want this radius property to be private. So I'm going to show you how to implement private properties and methods when using ES6 classes. There are basically 3 different approaches, but the first approach, in my opinion, is a terrible approach, so I don't even count that. The first approach is using an underscore as a naming convention. So some developers name their private properties or methods using an underscore. So they prefix it with an underscore like this, and then they assume that this is a private property. Why do I say this is a terrible approach? Because I can still access this radius from the outside. So this is not abstraction. This is a convention for developers. It doesn't prevent another developer from writing code against this property. As I told you before, with abstraction, we want to hide some of these properties and methods from the outside. So as we change them, we isolate the impact of changes to the containing object. We don't want these details to leak to the outside, right? So this is not a way to implement private properties and methods. Please do not use this approach. Now in this lecture, I'm going to show you how to use ES6 symbols to implement private properties and methods. And in the next lecture, I'm going to show you how to use maps to achieve the same thing. So in ES6, we have a new type, a primitive type called symbol. Remember primitives? We have number, string, boolean. Now we have another primitive called symbol. So I'm going to define a constant called underline radius and set it to a symbol. So symbol is a function we call to generate a symbol. A symbol is essentially a unique identifier. Every time we call this function, we get a new unique identifier. And note that this is not a constructor function, so we cannot new that up, otherwise we get an error. So here in the console, I'm going to create one symbol and compare it with another symbol. Look, they're not the same. So every time we call the symbol function, we get a new unique value. And we can use this unique value as the property name for an object. What do I mean by that? Well, back to our constructor, let me revert this back to radius. Okay, so you know that in JavaScript, there are 2 ways to access a property in an object. We can use the dot notation, like what we have here, or brackets. So this, we pass a string, radius, and we set it to this argument. So these 2 lines are exactly the same. Now, with the introduction of symbols, we can also use a symbol as a property name instead of a string. So here we can use this square brackets, underline radius, our symbol, right? And set it to the radius argument. Now I'm going to delete these 2 first lines. Let's see the impact of this change. So save the changes. Now we have a circle object. Let's log it on the console. So look at the property. It's called symbol. Now this is just how we see it internally. The name of the property is a unique value. So if we set multiple properties using symbols, the property names all will show up as symbol, but internally they are unique. Now you might say, but Mosh, this is not private because we still have this property here. Well, yes and no. Let me explain. So if I type C dot, look, we don't have that radius property anymore. We don't have underline radius. So we cannot directly access that property in code. There is a hack around that. Let me show you. So we have this method object that get own property names. I've seen this before. So let's do a console.log, call this method and pass C as an argument. We get an empty array because we don't have any properties, or more accurately, any regular properties in this object. But we have another method, get own property symbols instead of names. Now look at this. So this returns an array of symbols. I can get the first symbol. Let's store that in a constant called key. So this returns an array. I'm going to get the first element. This is just for demonstration, not something you should do. Now we have a key, so we can access C of key and then log it on the console. Then we get the value of the radius property. But we're not going to write code like that to access these kind of private properties. This is kind of awkward, right? So we can use symbols as a simple way to implement kind of private properties and methods. Now, how do we implement a private method? Well, earlier you learned that we can add a method here like draw. Now, to make this private, similarly, we can define another symbol. Let's call that draw. We set this to a new symbol. Now, instead of using this name here, we want to use our symbol. Now, in ES6, we have this new feature called computed property names. So we can add brackets, and inside of these brackets, we add an expression. When that expression is evaluated, the resulting value will be used as the name of a property or method. So here we pass underline draw. So this expression, our symbol, will be evaluated. We get a unique value, a unique identifier, and because we have put that inside of these brackets, that unique identifier will be used as the name of this method. So I'm going to save the changes. Let's log C on the console one more time. So we have this property, which is the radius property. And in the prototype where all these methods end up, we have another property. Look, that's our symbol, and that's set to a function. So that's our draw function, or more accurately, the draw method. In the next lecture, I'm going to show you how to use maps to implement private properties and methods.